We're solving problem 23 from the Amc 10B from 2018. How many ordered pairs A and B of positive integers satisfy the equation A times B plus 63 is 20 times the LCM of A and B plus 12 times the GCD of A and B, where the GCD of A and B denotes the greatest common divisor of A and B, and LCM A and B denotes their least common multiple. Okay, now the LCM and GCD seems very confusing. So we can set variables by letting x be the LCM of A and B, and let y be the GCD of A and B. And we just set these values to these values because it's gonna because this is essentially an algebra equation, but with the LCM and GCD, so we want to transform it into some sort of form that's easier to compute. Okay, so we can rewrite this equation as xy plus 63 is 20x plus 12y. And now the xy part, since these two, A and B and x and y, are equal, because essentially if these two numbers are being multiplied and you're finding the LCM, so basically the product of two numbers is equal to the LCM of the two numbers times the GCD of the two numbers. So that's why this is true. And we can subtract these from both sides. So we get xy minus 20x minus 12y plus 63 is 0. And, well, this still is factorable, even though it might seem a bit weird. So we can use Simon's favorite factoring trick, which is it works in this scenario when you don't have a square and y instead of just, you have two variables here, which is good. So this is x minus 12 times y minus 20 minus 240 plus 63 is 0. And we can proceed to move this to the other side to make it equal to, so we don't want this negative here. So this is x minus 12 times y minus 20 is 177. And now you can see values for x and y by counting out the multiples of 177. So you list them out and then find x and y, because they're not directly the multiples, because they're still the minus 12 and minus 20. You count them and see that, you look at the chart and see that only two of them work, so that is simply our answer.